Good morning, students. Our today's topic is very important. This is function. हम लोग रिलेशन पढ़े हैं, प्रॉपर्टीज ऑफ रिलेशन पढ़े हैं और उसी से रिलेटेड हमारा यह टॉपिक है फंक्शन. Function is also a relation, but each relation is not a function. So, relation, a special type of relation is called a function. आइए इसको हम लोग समझते हैं और फर्स्ट ऑफ ऑल हम लोग कोशिश करें इसको डिफाइन करने की, फिर हम लोग समझने की कोशिश करेंगे उसको कि क्या डिफिनीशन दिया गया है और उस डिफिनीशन के आधार पर हम लोग फंक्शन को समझने की कोशिश करेंगे. आइए, लेट x and y be two non-empty set, then the subset f of x cross y, that means Cartesian product of set x and y, is said to be a function if and only if for every element x belongs to x, there exists a unique element, say y, in y, such that xy belongs to f. And unique, this is here word unique, and for every, two term is very important. In relation, we know that each subset of two sets, Cartesian product of two sets, is a relation from one set to, from first set to another. But a function, a subset of two Cartesian product is said to be function if for every element of x belongs to the first set x, there exists a unique element in y such that xy belongs to f. Y is called the image of x. Y is called the image of x and denoted by fx, that is fx equal to y. So, and we call that f image of x equal to y, or simply image of x equal to y. This is the definition of function, and function may be known as the by other terms like mapping, or transformation, or operator. This is denoted by the function is symbolically denoted by f is a function from x to y, or simply x tends arrow y and f यहाँ पर लिख देते हैं, f जैसे ऊपर में भी लिख दे सकते हैं ये f. This is f is a function from x to y. Here we also read f is a function from x to y. X is called here the domain of f and y is called the codomain of f. X here x is called domain of f and y is the codomain of f. And the image set of image is called the range of the f. Range of f is the set of image, all image of x, that is, and denoted by fx. That is denoted by fx and defined as f capital X is the image of X. Set of the image of X. So fx, set of fx such that X belongs to X. And function is maybe many one, either many one or one, and secondly either onto or into, according as the formation of image. If the image of different element, different object of the domain are different, then the function is said to be 1. And if more than one element of the domain have same image in Y or codomain, then we say that the function is many one. And if all the elements of the domain are the image of some element of the domain, then the function is onto. And if at least one element of the domain which is not the image of any element of the domain, then we say that function is into. We can understand, take a simple example like this. Now we try to understand, taking a simple example. Suppose this set is A and this set is B, and A has element x1, x2, x3, and y1, y2, y3, and F is a relation from A to B such that x is related to y1 and y2, and this is y3. Then x image of x1 is y1, image of x2 is y2, and image of x3 is y3. So FA, the range of F is equal to set of Fx such that x belongs to A. This equal to y1, y2 and y3, and this is equal to also equal to b here. So we see here that every element of B R is the image of some element of A. So the function is onto. So the function is onto. So F is onto. Also we say that different element has different image. So the function is, so F is 1 1 1 1. Onto is also called subjection, and 1 1 is also called injection. And combine both 1 1 and onto, we can write F is bijection. So we can easily verify or conclude that a function f is of which types. Here A is the domain of f and B is the codomain of f. Easily. And take another example. इसको यही एलिमेंट रहने दें, सिर्फ कॉस्ट ये इमेज का फॉर्मेशन को समझें कैसे कुछ का इमेज हो सकता है y1, y2, y3. If this y3, this is y3 also, this is y1. Let us try to understand which type of this function is f. Whether f is a function or not. दोनों समझ सकते हैं. ये f, since every element of x has image in B and there is no element of B, no element of A which has not the image in B. And also we say that every element of X has unique image in B. So f is a function from A to B. And here, since every element has y2 element of B which has not the image of any one of the element of A, so this is into matrix, and fx1 image of x1 equal to y3 and image of x2 is also y3 and image of x3 is equal to y1. So since two elements x1 and x2 have the same image y3, so the mapping is not 1 1, because y3, the element of codomain y3, has two PD images in A, x1 and x2, which are not equal. That means two different PD images in A. So F is many one. So F is many one. That means if two or more than two images of domain of the function have same image in codomain, then we say that the function is many one. And since there is one element y2 in codomain, which is not the image of any element of the domain, so this function is into, and combine both, we can say f is many one into function. We can take another example like this. A, B, x1, x2, x3, y1, y2, y3, and x1, this x1. Suppose this, like this, and f is a function. Since x1 associates the element y1 in B, and x2 also y1 connected to y1, and x3 also connected to y1. So every image of x1 is equal to y1, fx2 is equal to y1, and fx3 is equal to y1. Since all the elements of the domain have same image in B, so this is called constant function. So f is, since therefore FA, range of A is equal to set of y1 only, set of y1, because y1 is the only image. So since only image is y1, so this is fixed for any element of the domain, so this is called constant function. So f is constant. And since there is one element y2 in B, which is not the image of any element of the domain, so this is, so f is into, and every element of more than one element of A has same image in B, so this is many one. So f is many one. And hence combine both, f is many one and into. Yes. Now we over the class. and some assignment, notes and some problems for you I am sending, and I am full confidence you can solve easily.
Yes, okay.